Hey, here we are. Yeah, as you can see, it hasn't been long at all. We are back to deal with our next question, volume 5, that says evaluate the cube root of x raised to the power 4 and fourth root of x raised to the power 5. So it's such a question, friends. It's very interesting and nice because, the way it looks, if you don't know how to tackle it, you may think this is complicated, but this is so simple. It's all boiled down to the principles of indices. You see, but we are dealing with indices, or what you call the exponents that are fraction. So that's why we say fractional exponent. Do you understand it? So here is our volume 5 of what we're supposed to do in this short period of time. But friends, I know you are ready. Please just pick your hot coffee and sit beside and gaze at what I'm about to do. It's so simple, it's not magic. Let's set the ball rolling without wasting time. Okay, so as you can see, this is the question. Okay, it's all what we see. It's a multiple. This is whole lot of expression here. It's multiplying this expression. Okay, so what do? First and foremost, we have to simplify the whole expression term. Now, if we look at it very carefully, okay, you'll see that we are almost there. Why are we almost there? Let's see. This one, okay, and this one, and this one as well. Okay, we have this one as well over here that we have to deal with. So if we look at it very carefully, then our issue is solved in the sense that because of the 3 here, it makes the whole expression a cubic root. Okay, and because of the 4 we have over here, makes the whole expression 4th root. Do you understand it? So this too makes our traveling easy, because over here we have 4, we have 3, okay, being that is why it's cube root. Okay, then here we have 3, 4. Okay, so 4 and 3, that makes them, this is a cube root and this is a 4th root. Okay, so now let's have a look at it and resolve it. Now, because of that here, this whole thing can be written as x raised to the power 4 all into bracket 1/3 multiplying, okay, the next one, which we know it to be x raised to the power 5 all over 1/4. Friends, if you look at this, it looks so beautiful because it's a gentle way of expressing this mathematics. It looks so beautiful, fantastic. You see? So you see, x raised to the power 4 all raised to the power 1/3 times x raised to the power 5 all raised to the power 1/4. Please remember that in indices, in indices, if I have a raised to the power x multiplying by y, this can be written as a raised to the power xy. You see, this expression is what we are going to use to do our multiplication. Okay, our multiplication. Okay, so let's have a look at it. Okay, so this, okay, as you can see, the whole expression like that. Because a raised to the power x multiplied by y can be written as a xy. Okay, so if you look at it, it's all the parameters are in x, or variables are in x. So the first one, okay, where we have the first one, when we have x raised to the power 4, okay, we'll multiply that. So it will be x raised to the power 4 times 1 over 3. Have you seen it? X to the power 4 times 1 over 3. So we bring our bracket close. And this is multiplying that. There's the next one, as we can see, we're still applying this principle. So you see that this will be x to bracket x raised to the power of 5 multiplying 1 over 4. So we close the bracket, friends. Okay, so as you look at it, it just is similar to the formula, the one I've highlighted below. Okay, so we know that 4 times 1 over 3, yes, will give us x raised to the power 4 over 3. Okay, we can still put bracket around it. And this next one will be times x raised to the power. You see, this will be x raised to the power 5 over 4. You see, so this time around we're not dealing with numbers direct. We're dealing with numbers and also fractions. Now, friends, look at this. We are very familiar to this very equation. So now we have x raised to the power 4 over 3 times x raised to the power 5 over 4. Friends, how do we go about this? How do we go about this? Now let's look at it. Let's look at it. So, you see, we are going to recap once more. Recap. In the principles of indices, when we did indices, we saw that if we have a multiplying a with different variables, or variable of exponent. Let's say this is x and this is y. This is always written as the a raised to the power the x plus y. Have you seen that? We know this all over the time, that if we have a raised to the power x times a raised to the power y, yeah, this is the first principle or properties of indices that says that the right hand side will be the summation of x plus y, x and y. So if we are going to apply the same method, okay, to this one, you see, they look alike, so it's this and that. If you see that this is x and this is also x, so we are going to take the common x and add the exponent. Okay, so now let's go back and do it the way it's supposed to be done. So now our expression, which is given as x 4 over 3 times x 5 over 4, now can be written as x 4 over 3 plus 5 over 4. Have you seen it? Yeah? The top one is just nothing but fraction. Okay, so let's make a mark around our fraction. You see, this is what we have to put the fraction we learned earlier in the lower classes into action. You see, so 4 over 3 plus 5 over 4. Let's deal with the fraction and see. So the fraction, okay, that makes our topic as fractional exponent is what we are going to do. So what do? our fraction, that means we have 4 over 3 plus 5 over 4. So how do we do it? Okay, we know for sure that we have to find the lowest common multiple, which is always 12. Friends, we know that the 3 will go to 12 4 times. So that 4 times we multiply by 4. This will give us 16. Plus 4, okay, also it goes into 12. 4 goes into 12. 3 times. This one goes here 4. So 3 times 5, that will give us 15. Alright? Now when we combine 16 and 15, we all know we are going to get 31. Okay? So we have 31 over 12. You see? So therefore, the x raised to the power 4 over 3 times x raised to the power 5 over 4 is giving us x raised to the power 31 over 12. So this is the final answer. Friends, this is so easy. Why? Because we have broken it down step by step without fear, without fear of making a mistake, or without fear of thinking that we cannot do it. See, as I keep telling my student, math is all application. Wherever you are being taught, you have to take it serious, because that's what you are going to apply. Okay, throughout your life. Okay, you are going to apply that. You see, now, is it difficult at all? Because this whole expression here, this whole expression, which is the factorization, which is the fraction computation, doesn't make anything different at all, because we have seen it before. Okay, we have seen it before. And when we solve it, our answer we had is that. Okay, so that is 31 over 12. So meaning the addition of the fraction gave us 31 over 12. So that is the final answer. I think we can go through once more for us to see how we can make it easier for those who are in doubt of what we are doing. So let's go up there and see. So the first part is the question given to us. That's it, we should evaluate that. Okay, he said we should evaluate it. And how did we move about it? Okay, so when we look at everything at all, we came here and we know this is the question given. Yeah, that question, let me change this one to a light blue. Good. So that question given is this. Okay, and that's the question. That's the question. Okay, and we're asked to what? Evaluate this. And what did we do? All what we did was, because of the 3 here, because of the 3 here, and also the 4 over here, we got rid of this. It's a sign over here, because this means cube roots. Okay, and this is what 4th root. So cube root means the whole expression term raised to the power 1 over 3, and this one, the whole expression term raised to the power 4. And when we realize that the variables we have in the box, in the square bracket, is the same as x, and this also x. So then we remembered that when we have expression like that, a raised to the power x, y, x multiplying y is given as what? A raised to the power x, y. So if that is the case, then we shift the 1/3 into this box, and also we shift the 1/4 into the box to multiply. And we know when we multiply 4 by 1 over 3 is 4 over 3. And we multiply 5 by 4 is 5 over 4. You see, friends, now we have been able to make the fraction easier for ourselves. So all what we do is remember again, the x over here is the same as x. It's not z or y, it's x. So because of that, we recapitulated that if when we did indices, okay, principle of indices, we saw that a raised to the power x times a raised to the power y. Okay, but as far as they are multiplying, it means the right hand side will be the summation of x and y, the summation of this and that. And that is the reason why we have a raised to the power x plus 1. So this is what? Something we have invoked because we know it. Okay, so by applying this to our question in mind, means we have to maintain the x here. You see, so x raised to the power 4 over 3 times x raised to the power 5 over 4. When we maintain x here, then the summation of 4 over 3 and 5 over 4. And when we did that, you see, 4 over 3 and 5 over 4. Look at what we've done. Okay, we'll go to a place that we now applied our fraction that we learned earlier from the lower stages of our education. So 4 over 3 plus 5 over 4. We know we have to find the lowest common multiple, LCM. Okay, so that will be 3 times 4, that will be 12 over here. So 12. Then we know over here, 3 will go into 12 4 times. Okay, so the 4 will multiply by 4 over here, and we have 16. And we know 4 goes into 12 3 times, friends. And we multiply 3 by 5, we had 15. The summation of 16 and 15 gives us 31 over 12. So meaning the whole equation boils down to x raised to the power 31 over 12. Friends, I think there's no crime for worry. So that's where we end of our fractional exponential volume 5. Well, I will urge on to stay on because it wouldn't be long. We will deal with the volume 6. Okay, but please subscribe to this channel so that a lot of people will know the good works we are doing over here. This is free. We're not charging any money. And also click on the bell so you will be the first person to be notified for the next series or the next sort of things we do. Have a lovely time and don't go away. We'll still be with you soon. Bye.